I'm sure you won't be surprised to hear that just like for a linear regression model, logistic regression models have assumptions that we need to make sure we are satisfying before we can trust the results of the model. There are 3 official assumptions of logistic regression models. The first is that we have a good linear model, and this should sound very familiar. It's mostly a formality. We want to make sure that we are including all the right variables, we're excluding anything that doesn't belong, and that the coefficients have a linear relationship with the log of the odds ratio. The second assumption of a logistic regression model is that we have no perfect multicollinearity. This is exactly the same as the second assumption of a linear regression model, and we check it in the same way. It has to do with relationships among the x's, and we can use the correlation function to check. And third, we have to assume that we have independent errors. This is the same as saying that we have independent observations, and this is very similar to the linear regression assumption as well. However, we have a different kind of error now because we can predict yes or we can predict no. And when we make a mistake, it's either that we're predicting a 1 and we get a 0, or we're predicting a 0 and we get a 1. So we're not off by some amount, we're off by a very specific unit of 1 when we make a mistake. So because our errors look a little bit differently, we can't use the charts we used to use. We can only test the assumption of independent errors with our intuition. So we can no longer use residual plots, and we can't use an ACF plot. The residuals have no distribution because they don't change sizes, and we can't test for autocorrelation because we have a binary variable, and we're not supposed to take correlations among binary variables. So for assumption 3, we have to completely limit our testing to just using our intuition. Now, which assumptions are missing here? Well, the fourth assumption of heteroskedasticity can no longer be a requirement because we don't have a distribution of errors, as I said. They don't vary in size, so they're not going to vary across observations. So we really don't have to worry about heteroskedasticity. And the fifth assumption is also missing, that normal distribution of errors. And that's actually missing by design because that was the reason why we couldn't use a linear regression model for a binary response. So having just these first 3 assumptions is not a bad thing. However, there are 3 additional requirements of logistic regression that we need to review. First, we need to have complete information. Second, we cannot have complete separation. And third, we need to have a large sample size. So with the 3 requirements and the 3 assumptions, we're going to be doing 6 tests to make sure that we can use our logistic regression models.